working on that particular data sets throughout the session. So if you are attending, if you are sincere enough to attend this workshop throughout the 5 days, so you will be eligible to put a skill related to data science on your resume. So if you are someone who are looking forward to get internship in the data science field, or data analyst, or any kind of that, so it will be a really uh, good thing for you. So yeah, and the perks about the event is like we will be sharing the certificates, and we just don't want you guys to get limit to this particular workshop only. So we will be connecting you all with the best data scientists we are aware of, and we will try our best to connect you with the best data scientists. And to get eligible for that, we have called that particular thing as one-on-one mentorship session. So to get eligible for one-on-one mentorship session, you need to be active throughout the session. And once you will be participating in between the session and all, then we will be shortlisting couple of folks who will be getting those mentorship from best data scientists, or from those who has worked in the field of data science. So yeah, that is one of the best perk of this event, I guess, because they will be mentor for you, like not only for this workshop, only for your whole life. So yeah, that's all. So we
Uh,
can move
so
forward.
like as we have already introduced ourselves, being as a lead, as a gold ambassador also, try to give a glimpse of the program microlearning student ambassador, like who we are and what we are and why we do all these things. So moving ahead with this thing, so microlearning student ambassador, what is it? It's a student ambassador community. Be it like who are they, like what we all do into this. We are just forgot the people. We are a collection of people, collection of students. We say who are just a collection of same mindset, who learns to grow, be a student leader, learn help others to grow, educate the community, and helps the student who cannot impede themselves to a more higher study of themselves. So I'll say that it's just connecting, helping, and growing together. This is all what we can say in a student ambassador community. Yeah, cool. So this is what we have started with data science demystified. And yeah, one more thing I'd like to say that whatever you are learning, whatever you are imparting, just impart on the social media. Do not forget to tag us. We try to share our socials on the chat itself. Do not forget to tag us on the socials. Whatever you are learning into the field, learn in public, and yeah, cool enough to stay into it. So I'd like to invite a speaker, Sanya Sinha, who will be getting us into the data science, who is one of our famous and quite virtuous data scientists among us. So yeah, cool. Over to you, Sanya.
Hi, am I audible and visible?
Yes, you are.
Absolutely right.
Okay, cool. So, hi everyone, I'm Sanya, and I'm going to be taking up the first session for Data Science Demystified. So, I'll just start sharing my screen. Just one moment. Can you all see my screen? Hello.
Yes,
Yes,
Sanya.
Yes, Anya, it's visible.
Okay, thank you,
It's
thank you.
absolutely visible.
So,
it's
hi
visible.
everyone, I'm Sanya, and I'm a Gold Microsoft Learn Student Ambassador. I work as a research intern at Carnegie Mellon University at ITBHU, and I used to work as a research intern at UT Austin and at the National Institute of Technology, Patna. I am a Kaggle master, I'm a Kaggle notebooks master, as well as I used to create the documentation for with the core team for NumPy at UC Berkeley's Berkeley Institute for Data Science. I'm very passionate about data science and I would love to make a final career out of it. And I would love to guide all of you in the process of finally creating a career in data science and creating a data science profile for yourselves. So without any further delay, let's get started with the presentation. So, what is data science? Data science is an amalgamation of two words, data and science. So, if you are completely new to this field, you can say that the science of understanding data is data science. And you are mostly correct. Data science is an interdisciplinary field. That means it is an amalgamated field. It is a field that is not independent. It is a mixture, it is a combination of multiple fields that deal with the intersection of statistics, computer informatics, and business analytics to understand and analyze the given data. This means that in order to draw insightful information from the data that has been provided to you, you need to use maths and statistics, computer informatics, mostly regular computer programming, and business analytics. That is, in order to create a business throughput from your data, you need an amalgamation of all of these subjects in in a succinct manner. You can say that you need data science in order to generate business oriented, insightful information from the given information, from the given data. So I hope you have a brief idea about what data science is. It is nothing but the science of extracting information from data. Fine. So if you're okay with this, let us proceed to the next slides. Where can we use data science? What are the applications of data science? So the applications of data science are innumerable, but these were the four main applications wherein I thought I could spotlight how you are using data science in everyday life. So in finances, the divide and conquer principle of data via customer profiling, past expenditures, and other essential variables to analyze the probabilities of risk and default. So if you invest in the market, you would know that in order to invest, you first take a look at the performance of the stocks in the past, and then you decide whether or not you want to invest in a particular venture or not, right? So you don't just randomly start investing your money in something, or start investing your time in something without knowing that it's going to have some returns for you. You are doing data science. You basically took a look at how a particular venture was performing in the past. You took a look at the data of the venture from the past. Then you created your own insight from it. You extracted your own insight from it. And then you were able to apply it for future financial predicaments. This is how you are using data science in the field of finance. This was a very layman explanation for using data science in retail and in finance. Mostly companies use them in order to clear the loans and the debts on the basis of customer profile data and past previous information about the customer. So I hope data science in finance was clear. Next up, we have healthcare. So, medical imaging for computer aided diagnosis based on diseased image data. So, traditionally, diagnosis is of two types. You have manual diagnosis, wherein scans are conducted on a person's respective body parts. For example, there are CT scans, there are MRIs, there are mammograms, stomograms, fundoscopy images, and so on. So, all these scans are conducted, and then these scans are consulted with a specialist. The specialist looks at the images of these scans and says whether or not a particular disease has infested a particular patient or not, right? So this is how manual diagnosis works. But this is a very time taking procedure, because first the scans are developed, then they are sent to a particular specialist. The specialist may not be an expert in the field, and he may diagnose the disease wrong, or he may not be able to predict the severity of the disease. Consequently, manual diagnosis extends the length of the diagnosis pipeline unnecessarily. And therefore, we were introduced to computer aided diagnosis. So, computer aided diagnosis mainly uses data science. Now, how does CAD or computer aided diagnosis use data science? So you basically train a model. If you're familiar with machine learning, you would know that I'm not expecting you to be familiar. I was just asking for a general perspective. So if you are familiar with data, with machine learning, if you have a slight bit of information also, basically you train a machine, you train a model in such a way that you feed image data into it. You feed what regular tumors look like, and you feed what patient disease or what disease tumors look like. And now you will be able to ask your machine to predict whether or not a particular tumor in a patient's body is malignant or benign. So with on the basis of previous data, on the basis of patient data, your machine would be able to predict whether or not a particular disease is present in a patient's body or not. This is how you can use data science for medical imaging and for disease diagnosis. You can understand the impact of the DNA on our health and find individual biological connections between genetics, diseases, and drug response. So, on the basis of genomic data, on the basis of genomic information, you can create the best line of action for a particular drug response on the basis of the genomic data that was provided to you for a given species. This is how you can use data, different types of data, image data, genome data, in order to synthesize viable medical responses in the field of healthcare. So, I hope all this explanation was clear. So, next up, we have targeted advertising. For example, I think all of us are very familiar with the principle of cookies. If you are looking up a particular product on Amazon, for example, if you're looking at data science courses on Amazon, sorry, not on Amazon, if you're looking at data science courses on the web, after 2 to 3 days, or not even after 2 to 3 days, after 2 to 3 hours, you would see a YouTube search recommendations, you would see videos of data science tutorials, you would see multiple edtech brands advertising their products, their data science courses on your feed. This is a result of targeted advertising that is achieved through data science. How is this achieved? By taking past user search data and customizing recommendation systems for each user to deliver targeted advertisements and product suggestions. These use nothing but your data, the cookies, the information that you had searched for previously in order to tailor customized recommendation systems for you that you would be interested in. Next up, you have search engines. Search engines like Google or Bing, they make use of data science algorithms to deliver the best result for a searched query in a fraction of a second. Consider the fact that Google processes more than 20 petabytes of data every day. Mostly what happens is that if you have searched for something repetitively, the Google search or the search engine search that you are running basically knows that this is a particular entry that you are interested in. This is the type of entry that you are interested in. If you have searched for data science in the past, it will only show you data science related content. It will show you computerized data science related content and not, lots of other surveys that you have pertaining to the statistical side of data science and so on. It knows, it has a general idea of what you are expecting from it, and that is where data science steps in. It is used to curate a customized performance report for a user profile. This means it only shows you the information that you would be interested in. These are the applications of data science in everyday life. There are innumerable other applications as well. For example, creating airplane routes, or for example, augmented reality. All of these somehow contain implications and applications of data science. So I hope I have made the expanse of the data science very clear, and you can understand how tremendous the impact of data science has been in the field of computer sciences. Now, misconceptions and career scope. So, lots of people I have met and lots of people I interact with on a daily basis get these three professions confused tremendously. So, I am here to break those misconceptions and introduce you to what all of these uh, careers, what all of these professions basically mean, and how can you differentiate between them. And basically, what profession are you interested in modeling? So, a data scientist will be able to take data science projects from end to end. They can help store large amounts of data, create predictive modeling processes, and present the findings. A data scientist basically works with the intersection of mathematics and computer science. She or he is responsible to curate the mathematical models and for predictive modeling. This means that once you have your data, you have analyzed your data, you would be able to perform predictions, you would be able to generate predictions based on the data for future uses. This is the work that is done by a data scientist. A data scientist is usually in charge of the entire data pipeline for the entire data project. And like I said, the main skills acquired by data scientists needs to be mathematics and programming. Communication is definitely important for everyone in the main. So a data scientist typically uses skills like SQL, Python, and R. Python and R are basically the programming languages that you would use in order to extract and analyze data. Next up, we have data engineers, who are also known as database administrators and data architects. Now, the work of a data engineer is slightly different from that of a typical data scientist. So, most data engineers are responsible for architecting, for creating, for curating, for developing the data pipelines that are useful in storing the big data. So, what is big data? Big data basically contains 5 V's. the data with a lot of volume, with a lot of variety, with a lot of velocity, with a lot of veracity, as well as with a lot of veracity, is said to be big data. So I will delve into the depths of big data later on, but mostly you get an idea of what a data engineer is. They are responsible for curating the big data pipelines. They're responsible for handling the databases that are responsible for a product. Now, as you can see here, they typically focus on the coding part, the programming part, cleaning up the data sets and implementing requests that come from data scientists. The main skill of a data engineer is programming. Mathematics is a supplementary skill. They are not mandated to use mathematics in everyday life. And a very important part of their curriculum, of their job, is to handle big data. And programs such as Hadoop, Apache Spark, NoSQL, as well as Python mostly. They make use of these types of products. They make use of these types of tools in order to ensure that their work is done. So, like I was talking about, big data, I would just use the ink annotations in order to make it clear. So big data basically contains 5 V's. I wanted to make this very, very clear. So the first V for this is volume. Volume means it contains a large bulk of data, something that contains a very huge, a tremendous amount. For example, I think in the year 2016 or something, the estimated mobile traffic was 6.2 exabytes. That is about 6.2 billion gigabytes per month. This type of data is what you classify as big data. So the big data, as I said, has tremendous volume, as expected. Next up, you have velocity. Velocity refers to the speed at which data transfer is required, the speed at which your data has to move in order to maintain the efficiency of the data pipeline. After velocity, you have variety. Data has a lot of variety. It is not just textual data or data in CSV files. Your data could be in image format, in the audio format, in the video format. So in order to deal with the variety in data, you need big data handling tools, like I said, like uh, Hadoop and Apache Spark. Once you have variety, you have veracity. Veracity basically refers to the accuracy of the data, how certain, how consistent is the flow of your data throughout the data pipelines. And next up, finally, you have value. What is going to be the business throughput of your data? How valuable is your data going to be in the business landscape? So these are the 5 V's. You can note it down if you would like to um, remember them. So these are the 5 V's associated with big data. Data engineers are responsible for handling big data. Next up, you have data analysts, who are also slightly similar to business analysts. They are mostly responsible for handling the business side of things. They are responsible for extracting insights from data. They are not responsible for predictive modeling, as was the case with data scientists. They are responsible for generating visual insights from data, and they use tools like Excel, Tableau, and SQL. They are mainly focused towards the statistics part of data. They are responsible for, like I said, creating interesting visualizations, graphs, plots. um, they are responsible for using tools like Tableau and Excel. Basically, Excel is an important tool for every data related job. You need to be familiar with Excel. You need to, have hands on experience with Excel if you want to work in the field of data. Anyway, so I hope I have made the differences between data scientists, data engineers, and data analysts clear. Data scientists are more mathematical. Data engineers are more inclined towards the programming part of the pipelines for handling big data pipelines, and data analysts are responsible for the visualization part of things in order to extract valuable information from the data present. So I hope this particular interpretation was clear. If you have any doubts, you could ask them. You could unmute your microphone and ask. Okay, so I don't hear doubts. So don't worry. I will proceed to the roadmap for data science, and then I would get to your doubts after that. So next up
Uh,
we have, yeah.
Before that, I want everyone I hope everyone is listening attentively. So we have something for you. I will be just sharing link in the chat. You all have to go to that link, and there you will be find some sort of boxes and drawing and all that stuff. It's kind of if you have played Scribble, it's kind of that. What you have to do, you just have to choose that particular one box and write your name there, and you have to uh, you have to put all the takeaways you are getting from this meeting. So that's all what you have to do. I have shared the link in the chat. You can use that particular link. I will pin that link. So yeah, that's all. We will be seeing at the end of the session, we will be seeing everyone's name there, and whoever it will be count in the reward system. So yeah, just go to that particular name and choose one of the you just don't draw random stuff there. What you have to do, you just have to type your name and just write the points which you are getting from this particular session. So yeah, that's all. You can continue, Sanya. Thank you.
Okay, thank you. So now I am going to delve into the process of the curation of a roadmap for data science. So a roadmap is something that a lot of people have asked me about. How do I start a career in data science? How do I start working with data? And so there is not a single way that you can adopt, because it basically depends on how familiar you are with the basics required to get a hands-on experience with data science, right? So I'll just start with my ink connotations again. So these three, the beginning parts of data science, programming, databases, and math, you first need to be very familiar with these three pillars of data science. Now you can choose them in any order. You can get with your maths done first, then you could do your databases, then you could go for programming, or you could get your programming done first, then go to maths, then go to databases. So the order for this particular box is completely up to you, but these need to be perfected before you advance into complex data science, before you start into data science basics mostly. So like I said, you need to perfect these three pillars. You need to get hands-on experience with programming. Now, programming, what sort of programming? Python programming. If not Python, you can use R, or if you have opted for the Andrew NG course on data science, which is a very popular course on Coursera. So you can also be familiar with GNU Octave, but I don't find GNU Octave to be very versatile. So I would suggest you to work with either Python or R. It completely depends upon you. I personally work on Python, and I don't have any suggestion. I don't have any preference. It completely depends up to you. Both these languages are good in some way or the other. They have their own benefits. R is more inclined towards the statistical part of data science. So if you have prior experience with statistics, you can definitely go for R. And I personally go with Python because I already had prior Python experience. If you don't work with Python, and if you don't like R either, I would suggest you go for GNU Octave. It is very beginner friendly, and I'm sure you would like it. Also, if you're looking for resources to learn Python, I think you could take up any course by Free Code Camp, because those are really nice tutorials. And if not, I would talk to you about resources for Python data science very soon. So stay tuned for that. Next up, you have databases. So I think everybody should have some basic knowledge about SQL. If you don't, then it's okay. You can take up any course on SQL that is available on YouTube. There is also a lot of handwritten, there is a lot of textual content that you can refer on sites like Geeks for Geeks or W3 Schools or Scalar Academy, even on Microsoft Learn for that matter. So you need to perfect yourself with SQL. You can also work on any other database that you would like. For example, many people work on Azure Cosmos DB, but for starters, I would suggest you to work on something like SQL itself. I think knowing SQL is more than sufficient for the time being. Next up, you have maths. So the mathematical part of this basically includes a very thorough idea about linear algebra. I hope my writing is understandable and you're not facing any difficulties. If you are unable to understand my handwriting, please let me know. I would try to write more clearly.
It's much
So
better than mine, so I guess like my teacher usually get understand like what I'm writing. So yeah.
nice. So first we have linear algebra, then you have statistics. So In statistics, sorry, there's no space. There is a particular domain known as probability, if you are familiar with it. Probability is the crux behind data science. I would suggest you to try to get as much hands-on experience on probability as you can. Try to take up lectures, try to there are lots of tutorials available by Stanford professors as well. There are lots of Stanford professor courses available on YouTube for free. You can definitely check those out. They explain mathematical concepts very well. You can also take up a course on NPTEL if you're interested. Um, but I would definitely suggest you to have a very strong hands-on experience with probability before you start data science, because once you're working on machine learning, many people straight away jump to machine learning. There are lots and lots of statistical terms that you won't be aware of until you perfect probability and random processes. That is the name of the subject that it's basically called, probability and random processes. So try to perfect probability and random processes and statistics before you proceed towards the main parts of data science. Now, this part of it is done. Let me
Uh,
just,
can you
yeah.
just tell more about random processes? Like we all are aware with the probability, but just a brief about like what exactly includes in the random processes.
Okay, so probability random basically means stochastic, right? So anything that does not follow a very fixed given pattern in basically in communication systems is known as random processes. This is more inclined towards the communication side of things, or as you can say, it is a side of mathematics that deals with the concept of a random variable when it is exposed to signals. So this is the gist of random processes in mathematics, in signal processing basically. But since you are more interested in data sciences, so random processes can include anything that are a process that are a function of time. So in order to say it in very layman's terms, random processes are basically functions of time, random variables which are functions of time. So all of these can be said to somehow contribute towards retrieving the final result in a data experiment. Every time you toss a coin, you perform an experiment, right? So different factors contribute towards the final experiment, the outcome of the experiment. Now now if these factors are functions of time, you will call them random processes. Now the example that I took was very basic, but there are a number of processes, there are a number of experiments that actually have a lot of factors that come into play. So for these, random processes are said to be the building blocks. They are said to be the basic features that contribute towards the final outcome. So I hope I was able to explain what random processes are.
Yeah, got it.
Okay. So once you have this done, let me just change the color of the ink. You have version control. So I think most of you are familiar with version control. Version control is basically Git and GitHub. Okay, so this allows you to continue making changes to your final document every time you want something to be changed. Version control is done. Next up, you have data science basics. Now, how can you learn data science basics? There is a very great website out there called cognitiveclass.ai. You can check this out for detailed video lectures. It's completely free. You will get badges also, badges by IBM, if you can complete the courses. It's basically a set of 3 courses, and it's really interesting. It will give you lots of great insights about how to start with data, how to get started with data science. There is another website called Great Learning. Many of you must be familiar with it. I personally used these 2 resources when I was getting started with data science. So it's actually a really great way to get started and to expose yourself to the very basics of data science and data analysis. If you have done your part of Python well, then you will face no problem in the data science basics part. Also, it's very important for you to learn EDA while you are covering data science basics. EDA stands for exploratory data analysis. You cannot perform any data science related activity without knowledge of exploratory data analysis. Once you are familiar with EDA, you can process, you can analyze, you can draw insights from any data, from any Excel file, from any spreadsheet, and you can use those insights for future use, for future reflections, and for predictive modeling as well. So
So
EDA
just
is
a
very
plug-in
important.
here, just a plug-in here. You have heard from Sanya that EDA is very important, and we will be covering EDA on the day 3 or day 4. And I don't remember it. So yeah, you will be learning that too.
Mostly you'll be getting to know everything that I am going to be talking about in this roadmap in this 5-day course. So definitely stay tuned for that. Now, once you're done with EDA, please note, this is a really important part. You Let's just say that you are a data analyst. You have derived some really interesting insights from the business data that was provided to you by your organization. Now you need to explain, you need to convey those insights, you need to communicate those insights to your boss and to the clients. So you just can't go and speak in very literal statistical terms in front of them, right? That the R value was so much, the ANOVA value was this much. You will have to be very visual when it comes to your presentations, right? You have to add graphs, you have to add figures so that it's visible, so that your success, your presentation, your findings are very visible in the public eye, to the public eye. Therefore, visualization of data is very important. Data visualization helps to see how far you have accomplished, and it's easy to the eye, you can say. It's more graphically appealing, it's more visually pleasing. So definitely visualization is a very important part of data. So for visualization, definitely Python is amazing, but there are other no code tools available as well. For example, you will be dealing with Power BI in this particular session. Power BI is really great. And if you're not familiar with Power, you will learn Power BI in session 3 or 4. So stay tuned for that. Also, after Power BI, there are tools like Tableau. So definitely check these tools out as well. I will also, you can take a screenshot of this as if you want. However, I don't think it's very clear. Don't worry, I'll write it all down somewhere and I'll pass on the notes to you. So after Tableau, we are going to talk about machine learning basics. So machine learning basics will, so what is machine learning? So machine learning was defined in early 1990s by the father of machine learning as the ability of enabling programs to perform computations without being explicitly programmed. This means every time your computer was asked to do something, it would have to be programmed, right? You need to do this again. So if your computer had the ability to perform on its own without extensive programming, without additional programming, it was said to be a part of machine learning. This means it would allow your computer to be partially artificially intelligent and take actions on its own based on some prior information that you had stored into it, based on some prior data that was entered into it. So machine learning basically comprises all the information, all the entire procedure of using data to generate insights, not by the individual but by the machine itself. Time series Time series is an abstraction of machine learning. I am not going into extreme details for time series right now because I think it is a little beyond our syllabus and we are definitely running short on time as well. So time series basically means forecasting and predictive modeling of data for future use. There are many time series models available like ARIMA, which will enable you to retrieve the results or retrieve the prediction results in a future time. For example, if you are, let's just say, if you have something like a company, and if you are trying to determine the cost of a particular product after a given span of time, after inflation and other factors that come into play. So after you want to account for a number of factors including time as a given variable, then you will be doing and then you will be performing time series analysis on it. So this is a little out of syllabus right now, so we will not be delving into it in this particular workshop, but there are various time series analysis projects that you could take up on your own and perform in order to strengthen your skills. Next up, you have neural networks. Neural networks, neural as the name suggests, belongs to the brain. So this enables you to create an artificial brain kind of structure that will enable your machine to take actions, to perform actions on its own. Neural networks are basically a machine learning algorithm called MLP or multi-layer perceptrons. Okay, so there are multiple machine learning algorithms out there. For example, support vector machines, random forests, k nearest neighbors, and so on. We are not going to be delving into the algorithms right now. Neural networks are also another type of algorithms that focus on recreating the brain structure through machines, through neurons, through artificial neurons. Each of these dots, that these spots that you can see here, are artificial neurons that have been generated artificially by human beings. So these neural networks are also a type of machine learning algorithm called MLP, multi-layered perceptron. Now you can use multiple MLPs, you can create dense neural networks, and once you are using dense neural networks in order to perform machine learning tasks, predictive modeling, or for classification tasks, you are performing deep learning. Deep learning is a slightly more complicated abstraction of machine learning that deals with using multiple layers of neurons in order to perform classification tasks. Deep learning, or CNNs as they are called, convolutional, there are different types of neural networks. So mostly we would deal with CNNs or convolutional neural networks, ANNs, artificial neural networks, RNNs, residual neural networks, and so on. So all these types of neural networks are responsible for performing their own sets of classification tasks. And finally, this is not a very important part because this further delves into very deep level of specification. Natural language processing, which is the ability of extracting data, of extracting information from textual data for linguistic information. This means, for example, like I give you the example of Google search. Your Google search is able to make sense out of the random words you enter into it using its artificial brain, using the Google brain. This Google brain uses natural language processing to process the information, to process the textual data that was entered into it. So natural language processing is not a very important part that you need to be focusing on right now, but it has tremendous prospect in the future. A lot of research is being done on natural language processing, and it is a very, very, very interesting field of data science. Natural language processing is also synonymous, it's not exactly synonymous, it's a counterpart for something called CV, or computer vision, as it's called. So, as natural language processing focuses on the linguistic side of things, it focuses on textual information. Computer vision, or CV, focuses on the image side of things. It focuses, like I give you the example of medical imaging, like I asked you that a particular brain tumor image was fed into a machine learning system, and your machine learning system was able to locate the presence of tumor based on previously entered image data. This is a part of computer vision. So this is the entire roadmap you could take in order to perfect the process of becoming a data scientist. This is very optional, these last two, because these further dive very deeper into a research side of things. But for the time being, this entire process is very, very important if you need to become a data scientist. So this was the complete roadmap to data science. Now, how to harness data. You learned the complete roadmap of how to become a data scientist. Now, I also suggested a lot of resources. There are a lot of resources available on Microsoft Learn also for helping you out. So I'll just tell you how can you do that. Just one second. So there are a lot of learning paths available on Microsoft Learn. These links would be sent to you by the organizers in the chat box. All you have to do is filter your search with AI engineer or data scientists, and there are a lot of machine learning courses available. You can choose any machine learning course of your choice. However, the one that I would definitely like you to focus on, first of all, is going to be this one. This is explore and analyze data with Python. Data exploration and analysis is at the core of data science. As I told you, exploratory data analysis is the essence of data science. Data scientists require skills in languages like Python to explore, visualize, and manipulate data. So there are a lot of important packages. There are a lot of important modules in Python that are responsible for data manipulation. Most of these are NumPy, Pandas, and Matplotlib for data analysis and visualization. These three are the core pillars of any data manipulation. So you need to have hands-on experience with NumPy, Pandas, and Matplotlib at least. And I think the best part about learning something from Microsoft Learn is that they give you access to a sandbox. So a sandbox is basically something like an experimental box where you can perform your analysis. Yeah, just like this. So you don't have to open a Jupyter notebook externally. You can simply run the code right here and your result would be displayed. So I think this is a really great initiative brought to you by Microsoft Learn. Hello.
Yeah, no,
I guess Someone's mic is open. Like, let me just change the settings. Yeah.
Yeah.
Sorry for that. Yeah, you can go ahead.
Yeah. Okay. So this was one course that was exploratory data analysis with Python. We have another course that you can definitely take up once you are familiar with the EDA side of things. This is the Foundations of Data Science for Machine Learning. So this particular course is available in three versions. So the first option of the first version is the complete course. It gives you a very, very deep understanding for data science. And I think it's the course that I took. It's an amazing course. It's a 12-hour course that you can take up in order to perfect, in order to completely understand the entire internal working of data science. It has topics like introduction to machine learning, build classical ML models with supervised learning, introduction to data for machine learning, explore and analyze data with Python. That particular course that I had shown you before this was a part of this 12-hour course. Train and understand regression models in machine learning. There are two types of machine learning models: regression models and classification models. Regression models are used when you are trying to predict a numerical output, and classification models are used when you are trying to predict the class of a given output. For example, we are going to classify different types of flowers into their respective categories. This is something that we are going to be doing very soon, so stay tuned for it. Next, you have refining and testing machine learning models. You have training and evaluating regression models. You have training and creating and understanding classification models. You have selecting and customizing architectures and hyperparameters using random forest. So random forest is a machine learning algorithm. And every once in a while, you need to tune the parameters that are responsible for building up a machine learning model in order to improve the results that you get on a particular task. Next, you have confusion matrix and data imbalances in order to find out if your model is actually doing a good job in the prediction or not. Measure and optimize model performance with ROC, that is receiver operator characteristics, and AUC, area under curve metrics. And then you have train and evaluate classification models, train and evaluate clustering models, which are unsupervised learning algorithms, train and evaluate deep learning models. So this is a very, very comprehensive 12-hour course that you can take up in order to get a very thorough understanding of machine learning. If you have the time, then definitely go for this course. And if you are not a complete rookie to data science, you can take up this particular alternative, that is the understand data science for machine learning path. This is not very mathematical in nature as the previous one, and it's very, very professional. So this means that if you want to make a career out of machine learning, this is the one course that you should take. And finally, you have the create machine learning models learning path. You can take up this course, which is, like I said, it's very professional, and it just helps you to perfect your prevalent machine learning skills. But if you're a complete rookie towards machine learning, definitely take this Foundations of Data Science for Machine Learning course. Now, if you are not interested in the way the learn paths are structured, there is a very, very nice course that was curated by Microsoft for beginners to data science. It is available on GitHub, and a lot of us were contributors to this course, including Tawkir and I. So we really worked a lot in order to make this course very, very efficient and very student friendly. So you can get access to this course on GitHub. The links will be provided to you by the organizers towards the end of the meeting, definitely. And this is the entire course structure: defining data science ethics, defining data, introduction to statistics and probability. It's very, very well presented, and it gives you a very thorough insight about data science. So you can use both of these courses or either of these courses. I would suggest you to go through either of those courses, because once you are done with either, you would definitely be able to perfect the other one, and you won't need that much time input as well. So this is also a very thorough understanding for data science.
I
It is
just
also an
want
AI for
to
beginners course.
add
Yeah.
one thing here. There is one contributor. If you have gone through this, can you just show the name of Jesslyn there? So she is one of the very significant contributor of this course, and she will be as a mentor for those who will be active participant for the whole workshop. So yeah, that was just a plug in there.
Okay.
Vinayak sir, you also forgot me. I'm also one of the contributors.
Oh
Yes.
damn. Anyways,
Continue,
so
please. Huh?
yeah, so these were the MLSA resources that you could use in order to get very deep understanding about data science. And it's really great if you are interested in this field, because not many people actually are able to delve that deep into the concepts, because it's very mathematical in nature. You need to be good at maths as well as at programming in order to get thorough understanding of the subject. But it's not complicated. It's one of the most interesting fields out there, and I definitely would like to see many of you grow up to be great data scientists. So now I'm going to delve into the project that we are going to be dealing with. So let's take a look at this. By the way, there is something called Kaggle. Kaggle is a platform for data scientists. Currently, there are 11 million people on Kaggle who take a look at Kaggle competitions, Kaggle datasets, Kaggle code, and participate in Kaggle discussions in order to increase their knowledge of data science. I am also on Kaggle, and I would suggest all of you to create a Kaggle account and to work to try to get as much hands-on experience on Kaggle as you can, because you have access to over a million data sets. You can try to perform as many hands-on experiments. You can try to perform as many hands-on projects as you can on Kaggle. So it's an amazing platform for you to learn and grow and to develop a career as a data scientist. So like you have stars on CodeChef, you also have a ranking system on Kaggle, that is novice, competitor, expert, master, and grandmaster. So you can also proceed to the different levels, and that improves your profile on your resume. So, anyways, enough about Kaggle. We are going to be talking about this particular
Excuse me,
iris
ma'am.
flower. Yeah, hello.
Ma'am, there are various courses on Kaggle. Like, could you please
Yeah.
guide a little about like how to complete a course? I got very confused when I started, and I could not complete one.
Okay, so there are lots of courses available on Kaggle as well, as she said. I haven't taken up any Kaggle course as of now, because mostly they are not as beginner friendly as I would want them to be. So finishing up a Kaggle course, I think, requires you to finish up a project. I haven't taken a Kaggle course as of now, so I can't pass on any comments regarding that. But if you are interested, can you please tell me the course that you were taking up? I might be able to help you out with that.
Introduction to machine learning. Yeah.
If you're looking for an introduction to machine learning course, I would suggest you to take up the one I just talked about on Microsoft Learn, this particular course. So this has this particular module specifically devoted to introduction to machine learning. I think this would be a really great substitute, and you would also get points on your Microsoft Learn profile. So you could definitely take up this course. And if you are looking for certificates for your courses, if you're looking for certificates to prove that you have actually worked on a course, you can log into Great Learning. It's actually a really great platform, and you will also get access to certificates if you work on Great Learning. So
Okay. Thank you.
And all of these are free, right?
yeah, all of these courses are free. Anyways, so I was talking about the iris flower dataset. This is the dataset that you are going to be using in this particular project that you are going to be taking up over the course of the next 5 days. Different speakers would come to you and they would talk to you about performing different types of manipulations on the iris flower dataset. So the iris flower dataset was basically introduced in 1936 by this biologist called Ronald Fisher in his paper, and since then it has been evolved as the hello world problem statement of machine learning. So it's really great if you could perform a number of data related manipulations and visualization on this given data set. It would give you a very thorough insight about what data science is all about. Therefore, you will be dealing with this particular data set in the upcoming projects. So if I'm going to talk more about this particular data sample, so it basically contains 50 samples each from three different types of flowers, from three different types of iris flowers. These are Iris virginica, Iris setosa, and Iris versicolor. These are three different types of iris flowers separated on the basis of their morphological characters. And there are a total of 150 entries in a CSV file. CSV stands for comma separated value, by the way. It is kind of like an Excel file, but it's not as complex as one. So it can be processed as an Excel document itself, don't worry. A Python package called pandas is used for data manipulation mostly, but that would be discovered, that would be talked about in the upcoming sessions. I'm just going to introduce the data set to you. So there are 150 rows in total. These 150 records basically contain five attributes: petal length, petal width, sepal length, sepal width, and the class. That means what species does it belong to? Is it Setosa, Virginica, or Versicolor? And in the end of this project, you will be able to create a classification machine learning algorithm, and you would be able to predict whether a particular flower is belonging to what particular morphological class based on its characteristics. So definitely do check out the rest of this workshop in order to learn how to perform such amazing manipulations on the given data. You can download Jupyter Notebooks on your system by installing the Anaconda package. Also, if you don't want to work on Anaconda, you can simply work on Kaggle itself by creating a Kaggle notebook for any data set that you would like. For example, this is a data set that is provided on Kaggle. You can simply click on New Notebook right over here. And once you have clicked on that, you will see a Jupyter notebook right here inside the Kaggle environment as well. You can click on code in order to generate new coding samples, and you can click on Markdown in order to, create Markdown as well. So this is how you can use Kaggle notebooks with data already available from Kaggle. So it's actually a really great method if you have really large data sets to work with that are available on Kaggle. You don't have to download them on your local computer and then perform the data related calculations. You can simply do it on Kaggle notebooks itself. If you want, you can make your notebooks public as well. You can make sure that a lot of people also have access to these. If not, you can keep them private as well. So you can take a look at how Kaggle notebooks work. This is my Kaggle account. So you can perform well in in competitions. You can work in Kaggle data sets. You can create Kaggle notebooks or code specifically, or you can participate in Kaggle discussions. And this is how you can level up through the different levels available on Kaggle. You can take a look at multiple other notebooks by other people as well on any topic that you would like to know. For example, if you want to learn about EDA, so see, there are so many notebooks available on EDA. You can specify whether you want notebooks or just discussion topics or data sets or competitions and so on. And accordingly, your results would be displayed. Anyways, so this was enough about the data set. This is the final visualization output that you will learn to generate using using the Iris data set throughout the rest of the sessions that we are going to be coming up with this 5-day workshop. So definitely do stay tuned for this. This is where I would like to end with my presentation. If there are any questions, feel free to ask right now. Thank you.
Hello, ma'am.
Hello.
Ma'am, how much Python knowledge is required for to become a machine learning to start machine learning?
In order to start machine learning, so typical Python programming is very different from the programming that you need in order to become a data scientist, right? However, you need to be familiar with basic Python data structures, with Python loops and conditional statements, and with Python functions also, in order to be able to work on data science. So this is this is everything that is required from core Python. Now, if you're talking about Python for data science, you need access to a lot of other Python libraries as well. For example, like pandas, numpy, matplotlib, seaborn, and so on. So that's why I advised you the name of so many courses that you could take up, which will enable you to know just how much Python is required for what particular project. For machine learning, I would suggest that you get yourself experienced with pandas, numpy, matplotlib, and seaborn. This is the bare minimum. These are the bare minimum libraries that you should use in order to gain access, in order to perform your machine learning tasks well. Otherwise, it's very, very simple. There is just one simple line of code that you need to run in order to classify or in order to perform a regression problem. I hope I was clear.
Yes, ma'am. Thank you so much.
Thank you.
I I just have to add one thing here. See, I want to tell one thing here, like it will take 2 minutes. Sanya, can I add?
Yeah, sure.
You, yeah. So see, you all are learning everything. You have come here and you have joined here and you are learning, but no one knows that you are learning data science, right? So how you will make sure that the people outside the world can know about it? Like you are learning something, you are growing some, you are every day upskilling. So for that, what you have to do, like what I personally do is like whatever I'm learning, whatever I am doing, I do share it in public, and that's what I guess Sanya has done also. So what you all have, I will advise one thing to you all, that whatever you are doing, like whatever, not only this workshop, whatever the workshop you are attending, whatever event you are attending, do share that on the public. Do share it in public, like either it can be anything like a LinkedIn, Twitter, Instagram, or whatever it is. But I do prefer Twitter and the LinkedIn too. So if you have attended this event right now, so just take the screenshot of it, take do keep the 5 points. Why I have told you about the taking the going to that particular link and writing about the summary of and all that stuff, because you can just share it with some other people, folks, that yeah, I have learned something this today. So that is one thing which is more necessary, because if you will not tell, no one gonna come and uh, back you up. So yeah, the one of the most important thing is learning public. So yeah, whatever you are learning, just keep posting it to LinkedIn, Twitter, or whatever it is. So yeah, can just take the screenshot of this particular meet and you can just share it on the LinkedIn and Twitter also. And you can take Sanya, me, and Tokir. Tokir will be sharing the IDs in the chat. So yeah, we will be also keep sharing it. So yeah, that's all, I
Vinayak,
guess.
Sanya, I'll try to take the stage as well. Like, I know like most of the thing has been covered, and Sanya has explained in a wonderful manner. I appreciate for that thing. It has been the core field of it, the beginning part, and the enthusiasm part was so much amazing. Like I have been from the DevOps part and the React development end, but yeah, learning from you people and seeing you people to grow into data science is really excited me to opt in into data science. So this is what I shall be sharing on the LinkedIn and Twitter as well, like how whatever I have learned, what are data sets, what are resources, what can be done, what after all these things, in a point-wise manner, in a bullet-wise manner, and tagging all of you using the hashtag which has been given or presented over the screen, and tagging you people simultaneously will help you to grow me in a faster manner. Tagging the MLSA people, which will let the people know like how MLSA are growing and how MLSA are working upon it. So yeah, as well as adding to this fact also, this will help me to keep a record of it, like how I learned that thing or that particular topic into my past. I'll get into that post, boom, I can revise it from there. Thank you all for being here.
It's great. I
So
have a
Vinay,
question in the chat, I think. There's a question from Nilay. This was really great. Thank you. Just one question. How do you figure which career you want to choose, analyst, engineer, or scientist? So, yeah, it basically depends on what you would like to do in your future. So, if I'm being very frank, data scientist and data engineer roles are more lucrative than data analyst roles, because a data analyst is typically just used to draw insights, right? They are used to draw visualizations or perform insights from data. However, data scientists are required for the entire data modeling. They're responsible for predictive modeling. They're responsible for running the machine learning algorithm on the data and then drawing insights. So definitely the performance of data scientist is much more mathematical and much more demanding than that of a data analyst. Consequently, it's more lucrative. It's more money making. Also, a data engineer is one who can work on DevOps as well, who has experience with the cloud as well, because typically data engineers are ones who work on big data, and it's difficult to store that volume of data on a local system. So DevOps engineers or data engineers basically need to have good cloud computing knowledge as well. So if you're interested in the cloud and you're interested in data, then you should definitely work as a data engineer. Also, it's very important for you to note that a data scientist is the one who is responsible for maintaining the end-to-end pipeline of a given data sample. This means if you're going to preside over a project, beneath the product manager, beneath the project manager, there is always a data scientist. So a data scientist is the one who is going to preside over the data related parts of a project. So I hope that cleared your doubt, Nile. Thank you. So I have another question by Laksh. Hello, ma'am. What all steps of data science path coincide with data analyst, and where does the path diverge? So thank you for that really interesting question, Laksh. Data analyst and data analysts are mainly responsible for, like I told you, for the visualization side of things and for just randomly extracting information and then presenting it in front of clientele, right? However, a data scientist is the one who is responsible for actually running the machine learning part of things. So when you start delving into machine learning, the data analyst relinquishes his or her role, and control automatically passes into that of a data scientist. So therefore, as soon as you start working on machine learning, the role of a data scientist begins. This is the main difference. This is where the paths of a data scientist and a data analyst diverge. Are there any more questions?
Okay, we will be taking questions for like next 5 minutes or something. Till then, like I'm just sharing the LinkedIn profile of Sanya in the chat. So you can just connect with her and spam your all of the doubts in her DM. So yeah.
Okay, I have another doubt. Hello, ma'am. I want to know about MLOps. So that's a very interesting question, Piyush. MLOps stands for machine learning observability. So what is observability in a machine learning cycle? Now, everything that is done by a data scientist is done in a static wireframe. Everything is done in a static landscape. Once you expose your data to real world scenarios, and once you deploy it in a production environment, the entire setup of the data changes. This means that once your data was affixed when you were running it on your local system, now data is susceptible to a lot of fluctuations, to a lot of variations in the real world, right? For example, it is exposed to risks from the market crashes, the market rises. All of these are various factors that contribute to the volatility of data, right? So if you're working on MLOps, you are responsible to ensure that you are able to make up your model, you are able to keep on updating your model with the changes that keep on affecting your data. This is how ML observability tries to, make up for every time your data fluctuates. This is the gist of MLOps. It is a really exciting field. You can work as an MLOps engineer as well, if you are interested in this field. Lots of parts like model monitoring and data drifting are some important cruxes of model monitoring of MLOps that need to be discussed. And data drifting is basically, I have a very short example for data drifting. Back in 2020, when COVID-19 was at its peak, lots of luxury brand companies like Louis Vuitton and Gucci and Prada that were supposed to manufacture perfumes, they started manufacturing sanitizers. And this resulted in a 600% influx in their profits. This was how they tailored the demands of the customers into a profit making scenario for them. This also resulted in a 1.5 billion dollar increment in the e-commerce industries, specifically in personal hygiene products during COVID-19. So this was a major drift in the shopping paradigms, in the shopping archetypes of a customer, right? Because typically customers didn't shop for that much sanitizers. But with the advent of COVID-19, the customer archetype, the customer shopping archetype dramatically shifted towards that of personal hygiene products. This was a major example of a data drift. This means that models that were trained before the advent of COVID-19 would now fail because of a number of personal hygiene factors that also entered into the classification or the regression wireframe. Therefore, this is how a number of factors can contribute towards performing a given predictive modeling task. So this was about MLOps. Is DevOps necessary for data science? No, it's definitely not necessary for data science, but it's definitely helpful to have knowledge of some cloud-based systems. Definitely, it's necessary for all of us to know about containers, for having a little slight information about Kubernetes, because if you're working with big data, it becomes very difficult to work on your local system. So that therefore it's very advisable for all of us to have some basic information about cloud computing systems as well, so that you can run your ML ops, so that you can run your ML algorithms on a cloud-based container. Uh, 1 second. There's something. Very. how Ansible and how Ansible automation and OpenShift help in cloud and data science. Ansible automation and OpenShift are not very instrumental in data science. They are just helpful when you are actually deploying them on the cloud and are then performing, multiple individual activities. This means that if multiple people are collaborating on a given project in the cloud, then you can use Ansible automation and OpenShift. What all things need to be done before tomorrow's workshop, like Kaggle, Iris Flower dataset. And so I think before tomorrow's workshop, you need to have access to at least the dataset. You can download it on your system. If not, you can run it on Kaggle notebooks also, like I showed you. You can definitely run it on Kaggle notebooks as well. You don't need to install any external dependencies on your system. Everything would be taught in the workshop tomorrow itself. So stay tuned for that. Any other questions?
Ma'am, can we become a data scientist in 3 months?
That, yes, you can. You definitely can become a data scientist in 3 months. I It basically depends on how many experiences you get and on how many projects do you get to do. So if you are able to, I think you can gauge your abilities on your own, and you can start calling yourself a data scientist the moment you are comfortable with manipulating and analyzing masses of data on your own without referring to Google for every single thing. So as soon as you learn to become independent and you learn how to process data on your own, you learn the entire workflow of the data science process on your own, you can become a data scientist. It doesn't matter how long it takes you. It can take you even a week, it can take you 10 months. If you become familiar with the process, you are automatically a data scientist.
Thank you, ma'am.
Links will be shared. I think they're shared on Teams. Um, they share it in the WhatsApp group also. Don't worry.
Do not worry. We'll be sharing the same on the WhatsApp group also. We'll be getting all the resources. So don't worry about that.
So I guess like everyone's doubt has been cleared. This short poll now. I just want to know like how many of you uh can answer this. So yeah, it's a like just it's more about like we can improve the sessions in the future. So yeah, have you all have started it? By learning public, I means like sharing whatever you are learning on the LinkedIn, Twitter, and all that stuff. So yeah, I guess the poll is visible to on your screen. Is it? I got only 8 responses till now. 13. Okay, 8% was waiting for my advice. Cool. 15. We will count down. So these all the responses will be saved, and yeah, so for the mentorship sessions, uh, to get you a mentor, we will select those who are most active. So yeah, this all will be getting recorded. So if you have not participated yet, so do it soon. I'm just counting down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, cool. Now I just want to know how was the session. So yeah. So if you have not, you can just read the session here. And if you have not started learning in the public, so have not started learning in the public right till now, so what you can do it today also. You can just click the picture of this particular session and you can just put it on the LinkedIn that you have learned something about data science today. You have learned these things from the Sanya today. So you can just take her there And yeah, the all the profiles are there in the chat. You can take me, Toki, Anushka, or anyone like whom you have found here. So that is the thing. And I'm just closing this poll in just 10 seconds. The countdown has started now. So am I audible?
Yes, Vinay, you are audible.
Yes, sir.
Yes, we can wrap it up. Yeah.
Yeah. Before going into that, I shall be announcing one thing. Like for tomorrow, be prepared. Like we shall be hosting Aditi Gulati, one of our MLSA, and she will be teaching about let's like how you can decode the data using Python and the local tools. You can just have a read aloud on the internet as well before getting into this workshop, and she will be having a hands-on about it, will be educating like or advocating like how you can progress into it. So let's have a cozy, and can we have a screenshot of it if you people can come off the camera? We start to
Yeah,
share it.
sure, but 30 seconds because I am just facing the problem and I don't want to get me.
Yeah.
So everyone, you can just turn on your camera. Be just clicking a picture and share it on social. So yeah, uh, no, only one has left. Give me 30 seconds.
Uh, People are somewhat comprehensive about learning in public. Let me repeat like how you can do it. Whatever you have learned, like iris flower or just about learned about somewhat data sets or how you can progress into it. Difference between data scientist and a data engineer. You can just write it down on Twitter on the LinkedIn. Just get it out in a bullet points and just tag us. Use and do not forget to use those hashtags which we were presenting and keep learning and keep having an eyes upon it. That's an example of learning in public, and that's how you can make a record and get an eyes upon the recruiter. Recruiter have an sort of eye upon it, like, hey, this is a person learning. So yeah, that person can be believed on or can be recruited for the same. Vinay, have you taken some sort of screenshot?
I guess we can take it. Like we can also use together mode because the Tokir, are you doing that?
Actually, on my Linux system, it doesn't have that feature.
Okay,
On
yeah,
G,
I will do. I will do it. Don't worry. I can see couple of
thank you, Vinay.
faces here. Can you all just turn on your camera? I will wait for
Yeah,
10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So I'm just taking the screenshot right now. Yeah, I can see couple of faces there. Yeah. Done, 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 done. Done. Okay, someone is turned on their camera late. Okay, never mind. I've taken the screenshot. Mm,
just share in the WhatsApp group as well in the chats also if you can. We will
okay.
get that thing.
Someone is coming as a like they have just tilted the phone or something like that. So they are just they just seem to be like sleeping on the seat
Uh,
this
I,
way.
I'm, I'm just curious about your hoodie, man. Like the
Bro,
Solana hoodie.
Bro, I am not in the WhatsApp group. Can you please add me?
Sure,
Uh,
sure. We'll be just sharing the link in the chat. You can join from there.
Okay, 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 okay. Thank
okay.
you.
Thank you, Akhilesh, for letting us know. Being
Thank
as
you,
a
bro.
co-host and the host, we should be getting aware of this.
Today's discussion was great.
Uh,
I
can you
learned
take
a lot.
screenshot more? Darshan has uh, see like Sanya had turned off her camera. She is a wavelength speaker, and we are the host. So if Sanya can again turn her camera, then we can. But yeah, cool. Do not worry. We will having session till Friday. So ah, she had insisted over her. Yeah, Darshan, please. No, Darshan. Darshan has no Darshan. Ooh, Abhishek, nice background.
So I was speaking for more than 30 seconds there and I was unmuted. So what I was saying, we don't want you all to get limited from to this all sessions only. So we will be just figuring out like how we can improve the communication between us so that we can improve more about this workshops and all these things. So yeah, I hope everyone has enjoyed it and thank you so much for joining in. And tomorrow's session will be gonna be very great, so stay tuned for that. We will be sharing details soon with you all. So yeah, I guess we are done with the photograph session or whatever it is. Formalities, things to be done to share on Twitter and the LinkedIn. So yeah,
And yeah, do not forget to share us, huh? Share us using those hashtags.
cool, cool, cool. So yeah, we can end it.
Sure, sure.
Just turn off the recording.